titanium or zirconia. Common applications. Now here you suddenly have the elderly, the handicapped person. Yes, where are the common applications? Factors that may influence success. Think about it, structure it in your head, and of course, based on what you found. Very shortly, repeat. These are the things you want to know. What things am I looking at for comparing? Always clearly define what you're talking about. That's the idea of the background. Why are you looking at it? Aim of your comparison. It is basically thesis aim, yes. What am I comparing? Which actual properties are you looking at? That's the second part of the aim. That is also in the research question. What information do I gain by comparing it? That's something you need in the discussion. Just a short example, 2 cups. I want to compare 2 cups, 2 methods, 2 sciences. Which ones? Describe, explain. Then, why am I comparing them? I want to find out something. Now that's the first part of the aim, the question. You don't just want to compare for the sake of comparing things. Compare to find out something. So, you need a reason. Maybe you want to find out which is better for camping applications. Now, what am I going to compare? Which measurable properties, outcome measures, do I need to compare to find out which one of them is better? That's the list I talk about. For these cups, it might be how much do they weigh, how breakable are they, things like that. If I can compare these, I can decide that one's better, that one's worse. And then, of course, hopefully the starter really tells you which cup is better for the application or which material is better. So try to arrive at this. That's a very short one. Aim to compare which are better suited. And these are research questions that I look at. What are the characteristics of the cups? Which are the demands? What are their properties? What other properties might play a role? Possible. And what reliable conclusions can I draw from what I found? It's always the same structure. General question, define it more, get to searchable questions, search the data. When you have sufficient amount of data, look at it, build your thesis structure. Speaking of data and thesis structure, speaking of planning before you write, people quite often just pick out 2, 3, 4 papers, so they get an idea, then they write down the outline, and fine. Not really. The best way to go, really the best way to go is to have as much as possible all material you need to write the results part before you start writing it. Yeah, several reasons for that. First, before you start writing, you know you have enough material. It's really quite a pest to find out at the end there's not enough, and you have to change things. That way, that's usually the way it's done anyway. First you get the data, then you write about it. You don't get a little bit of data and then write about it, and then get the rest and figure out you can't write about the way you planned to write about it. So if you have everything from the start, not absolutely everything, but maybe like 80% or something, what you use later, yes, a large part. Of course, that makes organizing your thesis and your result structure much easier. You already have everything, or most at least, that's supposed to go in there, and then you can just nicely arrange it. Very helpful. Okay, so much for the review. I just wanted to add a little bit about experimental thesis, because each year I do have some participants who do want to write one, or well, maybe later in life you actually want to publish something or publish some findings. Why not? Now for an experimental thesis, sometimes they also have thesis questions. Also quite often they have a hypothesis. Now this is something to avoid confusion. Definitions, hypothesis, theory. Do you know the differences? Definition, probably. Do you know the difference between what's a hypothesis and what's a theory? Yes or no will be sufficient. Or yes, the explanation would be good. Uh-huh. I know with the typing, you always have to wait around a bit, but well, we do have some time. To save that, sorry. Yeah, good sound strategy. Okay. You can tell me if it's really what you thought later on. Okay, definition is easy. Yeah, definition is simply an explanation of a term. So when we all use the term, we are all always talking about the same thing. Can be more important in writing than you think. You'll notice that when you read, that people use different terms for the same thing. Now, within your thesis, you should always use one and the same for the one thing, even other people call it differently. So sometimes it's necessary to define it at the beginning, saying if I say such and such, I mean this in the context of the thesis, even though other people might see this differently. Then you've made everything clear, and it's always clear what you're talking about. Now, that's easy, definition. Now, a theory in science is not really something you will have to develop in a thesis. Maybe it's not even a doctoral thesis, maybe, but not so much. A theory is, as it says here, it's really our idea of reality. I think it's a yes, almost. Theory replaces hypothesis after testing. A theory is made up of multiple hypotheses often after they have been tested. Yeah, a theory encompasses everything we know, we observed, we experimented, we calculated, we thought about, to give us the best possible explanation for certain aspects of reality. So a theory is what we currently hold to be true. That might change later time, but currently it is what we think is true and is real. Now, in common language uses, if we say I have a theory, it doesn't mean the same thing. Yes, I have a guess, it's speculation. In science, that is not the case. A theory is something, well, as well proven as possible at the moment. Hypothesis is a little bit smaller. Hypothesis is usually a statement, an assumption, yeah? That states a logical linkage of facts that can be empirically studied. So if we just talk about it in a normal language, say hypothesis is really a guess. In science, it's not. It is not a guess, it's an assumption of what should be true. And it's an assumption that can be experimentally disproven. The very important point about the hypothesis. It can be experimentally disproven. And that is usually why hypotheses are at the core of experimental studies. These studies are set up to be able to disprove hypotheses. Okay, so in science, scientific hypothesis assumes that we have a correlation between one or more variables. That one variable depends on the other in a certain way. It has to fulfill 3 criteria. First one, it has to be generally valid, not just for 1 or 2 or 3 specimens, but a general statement. Yeah? Not just a specific case, but in general. It has to be some type of if-then logic. If this happens or is true, then this will happen. That's the causality of it. There has to be some kind of causality in the hypothesis statement. And third, also quite important, it has to be possible to falsify it. Falsifying, oh yeah, that's one example for hypothesis. This one, higher household income leads to a higher degree of the children that live in this household. Okay. It's a statement. It also states a correlation of two variables. One variable, the household income, that's independent, and you say, depending on this independent variable, the second one, the degree of education, depends on the household income, so it's a dependent variable, and this will be higher if the household income is higher. If, then statement. If the household income is higher, then the degree of education of the children will be higher. First, it has to be generally applicable. Yeah, you can really apply to basically every household you look at, not specifying this. If then logic, yes, it's there, like I said. If it's higher, then the education will be higher. And it can be falsified. What does it mean it can be falsified? You know? Have you heard that before in the statistics part? I don't know if Connie talked about it. Waiting on writing now. Just not seeing anything. Okay, maybe it'll show up later. I'm not sure. Basically, to falsify means that for your statement, it can be proven wrong. Exactly. What does it mean? It can be proven wrong. That means an outcome has to be thinkable, likely, that does not conform to the hypothesis. For instance, with the household, it's possible, feasible, you have to have a household with a high income, and yet a low degree of education for the children. That would falsify your hypothesis. Now, before you say, well, of course, it's obvious and you can falsify everything, can't you? It can be a little bit more tricky, really.